Hello, everyone, and welcome to the Weekly Space Hangout for Friday, June 10th, 2016. I'm Fraser, Cain, publisher of Universe Today, and this week we've got a bunch of really cool stories for you. We're going to be talking about the Lisa Pathfinder, looking for letters on the moon, watching a black hole eat live. We're going to hear an update on what's happening with the Inflatable ISS module and what is going this week in Musk, what's going on with the Falcon 9. So, joining us this week, we've got a regular cast of characters. We got Paul Sutter. Hey, Paul.
That's right, we do.
We have all the Paul Sutter we can handle. We got Dave Dickinson. Hey, David.
Hey, first one I'm done live from Morocco here.
Is that what you're in? So you're using that fancy Moroccan internet?
Yes, we are. We're actually on the house internet right now, so we'll see. It's kind of pay as you go, so hopefully I haven't eaten through my 12 gigs yet.
It's possibly some of the most stable internet that you've been able to find, so I'm impressed.
Yeah, had to come all the way here to get it.
Right, you had to search the
world. We're
world.
blazing a trail for other travelers.
And we got Morgan Rehnberg. Hey, Morgan.
Hey, it's good to be back.
Yeah. Where are you?
I am in Cambridge, Massachusetts at the Microsoft Northeast Research and Development Center at ComSciCon, the Communicating Science Conference.
That is one of the best conferences that I've been to. So say hi to everybody for me. I had a great time when I was there a couple of years back, I guess last year. And yeah.
It's just really exciting to be with a group of young people who are all very excited about getting involved with careers in science communication. And I think it shows that we have a really bright future ahead of us.
Yeah, absolutely. All right. And finally, last but absolutely not least, we have a special guest this week, NASA astrobiologist Dr. Chris McKay. Dr.
Great.
McKay, welcome to the Weekly Space Hangout.
Happy to be here.
All right. So for people who have no idea who you are, and I guess they may not even know that there's the red planet Mars exists and that there's rovers crawling around on it, can you let people know sort of who you are and what you do?
Okay, sure. I do Mars science. I'm interested in the search for life on Mars and the establishment of a human base on Mars to do the search for life and to determine if Mars has a long-term future with biology in it, otherwise known as terraforming Mars. So I'm really keen on the idea of establishing a research base, a permanent research base on Mars. What got me to this show was the realization that to do that on Mars, we need to do it first on the moon. And so we've done some work over the last couple of years arguing that we've got to make a lunar base work before we can really seriously think about how to make a Mars base work. And that's what I want to talk about today.
Well, I got to apologize in advance because there's about 1,000 different questions all bouncing in they're all colliding right now. So before we get on to the kind of exciting future stuff, let's talk a little bit about the history of exploration and the search for life on Mars kind of up to this point. And you've dedicated your whole career to this. You've been doing this for longer than almost anyone I know.
Yeah, well, the history of Mars science started off pretty dramatically with Viking, 1976. I was in graduate school. That's what got me interested in Mars. It was the first and so far the only NASA mission to explicitly search for life. And the results came back. We were more confused than when we started. And NASA essentially gave it up. Now there's interest in going back to Mars. Its interest is growing. In the meantime, we've done a lot of what I would call geology missions. We know that there was water. We learned that every mission. It seems like every new mission has to claim that they've discovered water. So we've had new discoveries of water every couple of years as new missions go. But really, the fundamental picture hasn't changed. Mars was once Earth-like. The question is, did it have life when it was Earth-like? How do we find evidence of that life? Now, I personally think that the best way to search for evidence of life is with humans. Fairly sophisticated research base, I think modeled on the research bases like we have in Antarctica. There's a further motivation for sending humans to Mars, which is to address the fundamental and important and separate question, can humans live and work on Mars? Is this really something that we should think about as a possible future option? We all assume the answer is yes. but we don't know that until we try it.
Yeah, this is something that I actually bring up quite a bit. And you know what? I'm just going to jump to this question now because I've got a person to talk to, which is that, we talk about the challenges of settling on Mars, about that, that the day length is kind of similar to Earth, which is great. It's reasonably close to the sun, only, it's maybe only a little colder than Winnipeg, but not much. But there's the radiation, which is a very serious issue, and there's going to need to be some kind of protection, but you dig underground a little bit and you and limit your time out on the surface. But the big question is the gravity, right? The gravity on Mars is 30% that on Earth. What impact do we think 30% gravity is going to have on the human body over the long term?
You hit the nail on the head. That is the fundamental question. And if it turns out that Mars gravity, which is about a third Earth gravity, is okay, it's more like Earth gravity in terms of its biological effects, then all's good. These scenarios of long-term human exploration on Mars are possible. Because the other problems you mentioned, they're all surmountable. But we can't change the gravity of Mars. If, on the other hand, it turns out that 1/3 gravity is more like 0 than 1, then that's all she wrote for human exploration of Mars on a long term. We could go there and visit it for a little bit, but we're not talking about long-term human stays, much less reproduction and raising children. So the gravity is a key uncertain, and most mission designers, including those at NASA, just ignore the question and just assume that it's going to be fine. And so you see these images of huge cities on Mars and research bases where astronauts stay on the surface for years and years and everything's good. That assumes that the answer is 1/3 gravity is like 1. But we have very little data to support that. We have a lot of data at 1, and we have a fair amount of data at 0 gravity, or effectively 0. We have essentially no data at 1/3, and we got a couple weekends of data at 1/6 on the moon. The astronauts went to the moon. They've been there for a few days. That's not enough to tell us what the long-term effects on humans will be of gravity. And so I think we have to approach colonization of Mars as a question in this point. And so we need to set up a research base on Mars that operates for many, many years so we can address long-term questions on human physiology and long-term reproductive questions, not on humans, obviously, that's unethical, but on human surrogates, starting maybe with the proverbial white mouse and working up. If mice don't develop embryos and childhood normally in 1/3 gravity, I would be very reluctant to recommend to human couples that they contemplate moving to Mars if they're interested in having children. So these are fundamental issues.
Yeah. So this is, apologize to everyone. There's my Slack is somehow audio is going through the broadcast, but I shut it all down. So hopefully that click noise is going to disappear. Stuart Butterfield, you're welcome. Okay, so right. So I guess then, if we know that, that zero gravity or microgravity is lethal, we know that Earth gravity is fine. We have no idea. We don't have a long enough sample to know what the moon's like. Is the next kind of reasonable step to really start pursuing some kind of artificial gravity system, rotational, like what we saw in The Martian, or, to find out what happens with that artificial gravity? Or you feel like it's to send living species to Mars and then see what happens there?
Well, artificial gravity, rotating the spacecraft, may be a solution for the trip, but it's not a solution on Mars. And the trip is only 6 months. And if you're going to Mars for a long term, you might be there for several years. The hope is to be able to spend 5-6 years at a time on Mars. That really, artificial gravity is not an option on the surface of Mars. I think the next step is to set up a long-term base on the moon and see what 1/6 gravity is like. If 1/6 is okay, that's the moon, and we know that 1's okay, then I'd be pretty comfortable in understanding that 1/3 is okay. So the moon is a nice test bed. It's close. If things go bad, we can get people home fast. It's always right there next to Earth. So the moon is a lot simpler. We can address these questions. We can establish an understanding of what are the challenges of a long-term human research base on another world with a different gravity on the moon. And in the best case scenario that it works, we develop the technologies, 3D printing, whatever, biological recycling systems, and the gravity turns out not to be a showstopper, then we're all set to go to Mars, which is a much, much harder problem logistically. It's harder to get there, and the safety issues are much more severe, and if things go bad, getting home is a much more serious challenge.
Now, the current approach on looking at Mars right now is one of exploration, and I know that when you were working with the exploration rovers, I mean, your search was the search for water, like still is, as the primary investigator, the search for past water. Curiosity is searching for evidence that water was acting upon the red planet for a long time. The next rover is going to be possibly looking for the constituents of life. What happens to the prospects of the colonization of Mars if life is discovered and the contamination issues become larger?
Yeah, it's a good point. Let me just put a little editorial comment. All the rovers have been searching for evidence of life. Frankly, I'm tired of searching for water. Searching for evidence of water. I'm tired of searching for water. All right, Mars had water. We knew that at Viking. We knew that at Mariner 9. Let's get beyond water to organic material and life. And so I've been a voice within NASA, an abrasive, loud voice within NASA to move beyond searching for water and get to searching for organics and searching for life itself. But that really wasn't your question. Your question is, what happens to human exploration if we do find evidence of life on Mars? And that's a fundamental question. And in some sense, it's a paradoxical question because I think we're only going to find it once we sent humans, right? And so we then ask the question, what do we do? We find ourselves on another planet, we discover life, what do we do? And I think working through the logic, there's two possibilities. One, we find that life, and it turns out to be related to us. It's on our tree of life. And that's not impossible. Earth and Mars exchange rocks. Those rocks may have carried life. Mars may be no more biologically isolated from Earth as Antarctica is from North America. In which case, it's not a fundamental problem. They are our cousins. They're living in our guts. We all can happily cohabitate. The other possibility, and the one that I would prefer be true, is that we find life on Mars and it represents a second genesis of life, a completely different origin of life, independent of all life on Earth. That would be way cool. It would be proof that life is common in the universe by the 0-1 infinity rule, because we've gone from one example of life to two, and there's no such number as two in the universe. It goes from 1 to infinity right away. Bingo. We know that the universe is full of life. That would be a wonderful result, but it would have, I think, important implications for what we would do in human exploration. I would say we back off. Not just back off, we decontaminate. We pull back all the rovers we sent. They're contaminated, by the way. None of them are sterile. None of them are clean. We pull back all the effects of human exploration. We hit Control-Z. Control-Z, Control-Z, Control-Z. We undo everything we've done on Mars for the last 30 years. And it can be done. Nothing we've done on Mars so far is irreversible. It's all reversible. And then what do we do? Well, now the thinking breaks into two modes. One is we ignore it. We quarantine it. We leave it alone. We don't do anything. I think that's a mistake. I think we should take the attitude, we're here to help. If there's life on Mars, it's not doing very well. It's not covering the planet with light-absorbing pigment the way life on Earth has. It's not completely dominating the cycles of carbon and nitrogen the way life on Earth does. So we investigate that life and try to figure out what it needs to do better. And then we try to change the planet to allow it to do better. Now, you might say, well, that's kind of hubris and altering the course of nature. But isn't that what we do when we do CPR on somebody that falls over with a heart attack? And that's what I'm suggesting we do to Mars. So that's a very important question. What happens if we find life? And in some sense, most people that think about Mars don't think about that question or the implications of the answer. Sometimes I feel that we are like a dog chasing a car. We're not sure what we're going to do if we succeed.
Right. Well, and one of the other problems, of course, is that the solar system itself has only got, or, Earth and Mars really only have the next 500 million years to a billion years until the sun has, heated up to the point that it scours the planets of life anyway. So if all Mars life has to look forward to is the barest existence until the sun destroys it, then I can definitely understand. So let's talk about how you can help Mars life. And I guess one of the things you're talking about is this idea of terraforming. So what's going to be involved to restore, the garden to Mars?
Right. Well, the underlying assumption is that since Mars once was an Earth-like planet, any life there would favor Earth-like conditions, i.e., it would like liquid water. So then the problem becomes one of how do you get Mars its water back, presuming that life does like the water. And I think that's a safe assumption. Well, the fundamental challenge is warming up the planet. Well, that's something we know how to do. We know how to warm up planets. We are doing it on Earth. We have demonstrated that technology on Earth with surprising effectiveness.
Yeah, that's so
we
sad.
are implementing warming on the Earth at the rate of about 1 degree per decade. And that's stunning when you think about it. If we were to apply that same technology to Mars, only this time do it on purpose instead of accidentally, we could warm up Mars 1 degree a decade or even a couple degrees per decade. And in 10 decades, Mars would be warm enough that its poles would have melted, the ice caps would have turned into clouds and rain, and CO2 would have come out. You have a thicker, wetter atmosphere, not breathable, but thicker and wetter. And so it's surprising that we actually already know how to do what it takes to do to make Mars habitable for life again.
Right. So how do you feel about the current state of, 10 years ago, the concept of us humans traveling to Mars was, in the realm of Kim Stanley Robinson books and, the dreams of Bob Zubrin. But in the last couple of years, right, Elon Musk has sort of stormed onto the scene with SpaceX and really started to chart this course towards human beings, our destinies on Mars. And that has really invigorated, I think, a lot of NASA's thinking as well in a lot of the programs that they're doing as well. Where do you sort of land on that sort of balance between private and government efforts to actually colonize the Red Planet?
I'm a big supporter of Musk and SpaceX, and I agree with what you just said, that his activities in this area have created a significant shift in people's perspective and a significant shift in the facts on the ground in terms of the difficulty of and the possibility of doing missions to Mars. So it's been in my view, a welcome and important change. And that, along with other things, technology developments, better computers, 3D printing, electric cars, again, back to Elon partly, all point toward the ability to use things that we are developing on Earth in the context of sustainability to achieve sustainability on Mars and the Moon. The problems are in many ways the same. Biological recycling, power, clean, reusable power where you have no fossil fuels, repair, simple repair, custom repair, using 3D printing, and lowering the cost of transportation. All of those things have taken a big step in the right direction over the last five years even. And I think that has caused many of us to think now is the time to push hard for a long-term base on the Moon, followed by a long-term base on Mars, because all these things seem to be coming together in a way that means that going to the Moon and setting up a long-term base isn't necessarily all of NASA's budget for all of time. It could be done for some reasonable amount of, say, 10% of NASA's budget.
Would you say, I know that there are a lot of people at NASA, like you, I think, who these are the ideas that guide and really sort of channel your energy into what that future holds for the exploration of the Red Planet and in many cases bureaucracy or just the realities of working within the government and the kinds of commitments that you have in terms of employment and things like that have just kind of held it back, or things have stalled or whatever. So I'm I mean, as an insider, someone who has been involved on the other side working with NASA, does it feel like there's a revolution going on the other side as well, that people are quite excited, enthusiastic, or do you think, they see it more as a threat?
Well, there are certainly parts of NASA that must perceive this growing commercial space activity as a threat. That's inevitable. But I certainly don't, and most of the people interested in human exploration of the moon and Mars do not. They see this as an extremely supportive and enabling capability. If we can get private groups like SpaceX and now Boeing and other groups that have jumped in, SpaceX established the principle that a private company could make rockets, sell them to NASA as a private company, not as a government contractor, and make a business model on that and do great things, impressive things, and walk down Cape Kennedy with the President of the United States. And immediately a lot of other companies jumped on that. And so that has started I think, a movement that's going to result in much easier access to space and a broader base for access to space. There's no reason why NASA should be building rockets anymore, frankly. We can be buying them from commercial vendors who are competing with each other to sell them to us. So why are we building them ourselves, right? That doesn't mean we're going to immediately stop, because there's a lot of inertia in the system on that. But I don't think that we can compete. Eventually, folks like me that want to go somewhere and say, well, why should I be spending a lot of money for an in-house rocket when I can be buying one on the marketplace for half the cost that does twice the performance? So I think it's going to revolutionize space transportation. We're seeing the start of it. And that's an important step toward enabling a low-cost lunar base, which I see as an important step to a low-cost Mars base, which I see as the important thing we need to do to get to these fundamental questions about life, past and future.
All right, so I'm going to take some questions from the audience now. So I got a couple here. One is, this comes from Valdegas, which is that every hour of every day, the U.S. is burning 100,000 tons of coal. How do we get that and the oxygen to combine with the coal to create carbon dioxide to Mars? No
way.
Obviously, it doesn't make sense to carry it off to Mars, but I think that's the point, is that, right, we've got too much greenhouse gases and Mars doesn't have enough.
Right. But we looked, that was the first suggestion by Jim Lovelock and Michael Allaby, was let's carry our greenhouse gases, not CO2, but super greenhouse gases, to Mars in rockets. But if you do the numbers, even if you only needed a part per million of these greenhouse gases, I calculated you need something like 10,000 shuttle loads to carry it to Mars. It's just ridiculous. You can't carry quantities of material from Earth to Mars sufficient to influence the atmosphere of Mars, even at the part per million or part per billion level. You've got to make it on Mars. You've got to use solar energy on Mars to make the compounds that are going to be released into the atmosphere to warm it. You can't bring them literally from Earth. You need to just bring the knowledge of how to make them from Earth.
Yeah. I think Zubrin was sort of talking about, the really exotic chlorofluorocarbons in factories that are pumping out the greenhouse gases on Mars that could then really thicken and warm the atmosphere to the point that things could warm up. That's right. The most. I mean,
the carbon and the fluorine that are in those greenhouse gases would be on Mars, and we know there's carbon in the atmosphere, and now we know there's fluorine in the rocks. So we know that the elements are there.
What do you think about the recent comments from Jeff Bezos that that we know that Earth is the nice planet and that we should really try and get the heavy industry off our planet and just keep Earth as the garden and then get all of that mining and industry off the planet?
Well, that may work. I don't have much insight in that. I'm focused really on Mars and the question of life. Life in the past and life in the future. What we do with industry on Earth, maybe even better would be not to have any heavy industry at all. I think heavy industry, we will look at it someday the way we're now looking back on wooden ships. It was a technology phase with nanotechnology and smart systems. We might get to a mode where we don't have heavy industries. We're doing technology by moving atoms into the place where we want them to, atom by atom. We look at the way plants produce sophisticated biomolecules. They don't have vats of chemicals and smoky fumes. They have enzymes that move molecules exactly to where they need to go. And if we move our industries into this smart mode, where we're essentially manipulating atoms and putting them together in the orientation we want, why do we even need heavy industry in space or anywhere else? So I think that comment, move heavy industry off Earth, is a solution to a problem that we're going to realize is a temporary problem in industrial development, and it will go away as we get smarter.
This question comes from Brian Yuko. What is more frustrating when searching for life, false positives or false negatives?
Well, they're both frustrating. They're both frustrating, and we have experienced them both. But more embarrassing are false positives, where somebody in the community stands up and say, "Hey, everybody, I found alien life. This is a second Genesis. It's like nothing we've ever seen before." And everybody gets so excited, and then it turns out that it's bogus. So that's more embarrassing. False negatives, of course, don't get any press. They're not embarrassing, but they're just as frustrating.
All right. Well, Chris has for some reason disappeared here, so I'm going to take that as the opportunity to let me just see if I can fix that. I know we're nearing sort of the end of your time, so I'm going to. Oh, there we go. I found you. All right. Let me see if I can bring you back here. Great. Okay, so I think we're sort of nearing the end of our time with you, Dr. McKay. So I really want to, thank you for joining us here on the Weekly Space Hangout. It was a total honor to have you join us. And, I want to thank you for just like your dedication to the exploration of Mars. I mean, you've been carrying this torch for literally for the entire time that I've been reporting on space news. You've been one of the people that we've been reporting on, and I've been doing this for 17 years. So, and it looks like you're still going strong. Yeah, and it looks like you're still going strong. So I think it's, you got a few other responsibilities I can hear, but still, at the end of the day, Mars is in your heart. So thank you so much.
It's the first day of summer vacation. All right, it was good talking to you guys, and good luck. Bye.
Where can, if people want to sort of follow on the search for life on Mars, where should they go?
Well, there's lots of information on the net, and if they want to email me, they can find me. Google very easy, Chris McKay NASA. I pop right up.
All right, wonderful. Well, thank you so much, Chris, for joining us, and we'll talk to you later. If you do find life, let us know. Can you come back and tell us?
Will do, and I won't bring a false positive.
Okay, all right, thanks. Okay, great. So Chris is going to drop out. I'm going to reconfigure the windows, and we're going to get on to the next person. So let's start with Dave Dickinson. Get ready, Dave.
Off mute.
Off mute. Off mute. Dave off mute. Yeah, now you're Paul Matt Sutter in my window here.
Uh-oh. That's not good.
Sorry about that.
Hold on. So just to let people know, this week, Chad got into his, my producer and director, got into his mind that he was going to go traveling to Costa Rica. And so now, now he's actually joined us here from Costa Rica, but he's not actually running the show. I am doing the whole thing by myself. So that is why, unfortunately, we don't have all of the cool effects and stuff that normally Chad brings to the table, but hopefully we'll have that next week. I also want to say a big thank you to all of the folks from the Weekly Space Hangout who have been, Weekly Space Hangout Crew, who are really the producers and the fans, the producers. They lined up that guest and all of our guests, and they're working really hard in the comments and sort of help keep things organized. And I really want to thank them for all of their efforts. So, Dave Dickinson, let's move on to LISA Pathfinder.
Yeah, it was an announcement earlier this week that from the European Space Agency, they're getting the first science results from the LISA Pathfinder mission. This is a gravitational wave detection demonstrator. It's not going to detect gravitational waves itself, but it was launched last December 2015, and sent out to the L1 Lagrange point, 1 million miles sunward, to a very gravitationally quiet area where it was going to test its key technology for the eventual launch of LISA, which is the Laser Interferometry Space Antenna
Oh no, we're losing you, David. David, you're breaking up. That you've used all your gigs.
Originally, been saying your internet connection unstable. I'm getting a message here. Let's see if it stabilizes.
Yeah, you're okay now.
Okay. Lisa Pathfinder, one of the key things, in case I break up, I'll throw in there, is it exceeded expectations for a technology demonstrator. It's not going to detect gravitational waves itself. The full-up Lisa mission for 2034 is what they're aiming for, where it's going to be 3 spacecraft flying in formation with a 1 million kilometer baseline. You can think of Lisa Pathfinder as taking that 1 million kilometer baseline, shrinking it down to 2 little tiny platinum gold test masses inside the spacecraft that are 30 centimeters apart in a vacuum. And they actually exceeded their expectations by a level of 5 times. They wanted to get to the picometer scale, which is like a millionth of a millionth of a meter. They actually got down to detect noise down in the femtometer scale, which was 5 times better than that, down toward about the size of a charge radius of a proton, to give you kind of a scale. Again, they're not detecting gravitational waves. We want to put a gravitational wave detector out in space, because detectors like LIGO that made the first direct detection recently on Earth, they have to contend with earthquakes, land tides, the sun, the moon, everything that is making it noisier. I went to LIGO in Livingston and the one up in Washington State. They have to contend with traffic going down the I-10 corridor in Louisiana. All this shakes the detector more than they detect nuclear tests in North Korea. I mean, it's crazy, the kind of things that shake this detector more than a passing gravitational wave. Now, with LISA, to put that out in space, you're taking all that noise out. The only kind of noise they have in LISA Pathfinder is these stray gas molecules that are still in the vacuum chamber that are occasionally hitting the test masses. And those are being vented out, and they say they can actually see it getting quieter as they're venting out over the past few months. So this is good news, that it shows that a full-on gravitational wave detector in space is viable. So, and things have been moving and shaking in gravitational wave astronomy this year. You got to remember, this is a window in the universe that is completely off the electromagnetic spectrum. So it's going to be it's kind of a new era of astronomy.
Yeah, one of the things that I keep bringing up is just how gravitational wave astronomy is going to open up vistas that have been completely hidden to us in the past. You know, in theory, we're going to be able to get a better sense of what happens when black holes merge, neutron stars colliding, some of the most extreme events in the universe. We're going to suddenly start to be able to see these things.
And LISA is going to be tuned to kind of a different frequency than LIGO. It's going to be looking for very low frequency gravitational waves. It's going to be looking for galactic mass mergers and things that are happening. LIGO is the LIGO detection were stellar mass. I believe they were 30 solar mass mergers that they detect there on their first detection. And LIGO didn't really give it gave a very vague direction as to where they came from. LISA is going to be able to pin this down with its going to have a 1 million kilometer long baseline, and it's going to be able to see as the gravitational wave ripples through the 3 detectors, it's going to be able to see them down to the scale of about 1 arc minute. Now, full moon is about 30 arc minutes across, so we're going to be able to pin them down. The one LIGO detection, there was some discussion, I believe it was Fermi, found a gamma ray burst within the same second that happened, and there's been a lot of discussion if that gamma ray burst was related to the LIGO detection we just don't know, but it's kind of interesting to postulate what might have been. LISA will be able to have much finer resolution on the sky.
Awesome. All right, let's move on to Paul Matt Sutter. Speaking of black holes and things we're going to be able to see with black holes, Paul, when do I get to watch a black hole eat something live?
You can do it now. Isn't that the amazing part of modern astronomy? I mean, who hasn't wanted to watch a black hole eat something?
Are we waiting for anybody to jump in? Nope.
Anyone?
Okay.
No,
all right.
Okay, just me as usual. It's cool.
So just tell me how.
So astronomers at ALMA, the Atacama Large Millimeter Array down in Chile, we're looking around, looking at supermassive black holes and their accretion disks. And there's been this kind of debate or wondering about how exactly black holes, the supermassive ones at the centers of every galaxy, of how they grow. We know they grow by sucking down their gas, but we didn't know if it was just kind of a steady trickle, a little stream, kind of constant, always there, but a small amount, or if they went on binges and would suck down big globs of gas every once in a while. And these recent observations from ALMA, they actually captured a black hole. They captured a big cloud of gas, a big dense cloud of gas in the act of falling into the black hole. And so they were able to see this because they saw the general light from all the hot gas as it's swirling and falling down into the black hole. And they saw a shadow of a dense clump kind of against that light. So they are able to detect this dense clump separately from just the diffuse glow. And that tells us that this black hole, at least at this time, feasted on one very, very large clump. Now, we're interested in this for a few reasons. One, because black holes are cool anyway, and we just want to know all about them. But also the rate at which black holes feed at the center of galaxies appears to be tied to the rate of star formation. So how fast stars form in the rest of the galaxy. And, we'd like to understand that connection, understand that process, understand how quickly stars form in galaxies, how often, whether it's erratic or continuous and all that. And it's observations like this that help us out.
So I got a question here from the physics police, who has actually been very helpful with my videos, catching mistakes that we make on the Guide to Space, and actually gets a shout out in an upcoming video. But anyway, physics police asks, is this gas being sucked from the accretion disk or from nearby stars?
It appears to be in the accretion disk itself, or accretion region.
Now, one of the developments that's in the works right now is this idea of the Event Horizon Telescope, right? And that's going to be a radio telescope, an Earth-sized array of telescopes, all working together to actually see the right up to the event horizon of the supermassive black hole at the heart of the Milky Way. So Let's say that thing was operating. What more would we be able to see based on these observations?
Right. So there is certainly gas in the vicinity of Sagittarius A star, which is the name we give to the black hole in the center of the Milky Way galaxy. Our supermassive black hole is relatively quiet right now. It's calmed down. It's already had its feeding, binging phase a long time ago in the past. And so it's just kind of hanging around near the center of the galaxy, not doing too much right now. So we probably wouldn't see one of these massive catastrophic events. It's only when we look at very distant galaxies, which are very young galaxies, where this kind of intense feeding phase tends to happen, where we can see these the events happen.
Right. Well, it's a pretty great time to be looking at black holes, and I can't wait. It's
never not a great time.
Never not a great time, and as you said, a good time to watch black holes feed. So. All right, well, let's move on to Morgan Rehnberg, who's still there. I know you might have forgotten about him. Let's talk about the ISS inflation module inflation.
Indeed. A couple of months ago, we reported on the fact that one of the SpaceX cargo supply launches to the International Space Station delivered this thing called BEAM, the Bigelow Expendable module.
Atmosphere.
It's not.
I know.
Awesome.
Awesome module. Yeah, the Bigelow
Expendable awesome module. And what BEAM is the next generation of possible technology for developing space stations. Rather than sending up these big metal trusses to basically encase our astronauts in tin cans, the idea in the future is, well, let's encase them in plastic bags instead. Because inflatable modules are smaller. You can pack more of them into the same amount of space because you don't need that interior space until you're actually trying to put an astronaut in it. And they're lighter because air is lighter than metal. And the ISS, a big metal space station, serves as the ideal testing ground for this next generation of space building technology. And since we've had our last episode, they've successfully inflated this module. And it took them 2 tries to do it, but they finally got it inflated and open. And for the first time this last week, an astronaut actually went into this inflatable module and checked it out and found that still breathing. And
that's good.
Everything seems to be working as intended. And the astronaut installed some measuring equipment inside of the beam and then left and sealed it back up. And they're going to leave it sealed now all the way through August. And the idea here is to find out whether it's got a leak. Because we often know if you're pumping up your car tire or your bike tire that you can fill it up with air and it feels sturdy, but then you come back 3 days later and you have a flat tire again. And so this long-term performance of an inflatable habitat is exactly what the beam is designed to test. And so the equipment installed will make measurements about the conditions inside of this module, as well as the physical structure and conditions of the module itself, periodically over the coming months. And then engineers back on the ground will be able to analyze that data and tell us whether or not the design we have now for inflatable modules is one we'll be able to extend and use for larger structures in the future.
Yeah, I mean, if this works and it can hold its atmosphere for a long time, it's going to be a great way for astronauts to be able to have some real space up there. I mean, right now they really do seem like they're trapped in a tin can and don't have a lot of space. So what you can imagine, the more they can perfect this technology, they can have huge open spaces. And of course, the astronauts are flying around in 3 dimensions, so they can kind of go anywhere, right?
Right. The method we used to build the Russian space station Mir, the American space station, the Chinese space station, these are not sustainable methods for us to build large, long-term structures in space because it's simply too expensive to launch that amount of stuff up there. But if we could launch 5 times as much stuff in the space it took to launch one space station module, then we could launch either very large space station-like structures, or multiple that could form multiple space stations, or form redundancies for a much longer-lasting space station that could then carry humans elsewhere into the solar system.
Yeah, awesome. I'm really looking forward to it, and I really hope that the next, that it holds the air, and they're able to continue on attaching larger and larger modules like this into the future. I mean, it's going to be, I think we're going to see inflatable habitats play a big role in almost everything. Well, I got one question that came up. What about the, I've got, guess 2 people, Warbash and John Suffield, were asking, really, what about the durability of these things compared to the tin can that we talked about?
That's exactly what this test is designed to study, because space is not completely empty. It's full of all sorts of little bits of space junk, both stuff that humans put up in space, but also micrometeorites and other bits of dust that are just floating around space. And these take a wear and tear onto the ISS. You might have seen this picture posted about a month ago by an astronaut showing this big divot that had popped into one of the windows on the ISS. And they thought that that had been formed by like a little fleck of paint that had flipped off of somewhere else on the space station. And metal, for all its problems, is a strong substance, and it's capable of surviving that day-to-day wear and tear of being exposed to outer space. We don't know yet about the kinds of plastics that have been used to build this inflatable module, whether they will be able to have the same sort of lifetime. But the only way to know that is to try it out, and that's exactly what this experimental module is designed to do.
Yeah, fantastic. All right, let's move on. Let's go back around and talk to Dave Dickinson again, and this time let's talk about how much of the alphabet we can write on the moon. Now, I know we can do O.
Yeah, there's plenty of O's. There's no shortage of O's on the moon.
Yep.
This is kind of, it's more of a observational artistic challenge than anything with any real scientific value to it. But it's something that we put out and we've been working on over the years of trying to flesh out a lunar alphabet. You think of what Galaxy Zoo did with writing your name in galaxies and these different shapes of galaxies. There's certain features out there that observers have noted on the moon over the years that resemble lunar letters, and there's been various collections put out on the web of these, and we've been trying to fill out this alphabet. One that's famous that you'll be able to see Sunday night on the first quarter moon is the Lunar X, also known as the Purbach Cross. This is a confluence of 3 older crater rims in the lunar highlands that form kind of an X-shaped feature. And it's really kind of dramatic if you see it when the sun rises on it, because what you get is the sun hitting the very top of it, but the base of it is still in shadow. Now, the day on the moon from sunrise to sunset lasts about 2 weeks. But it's interesting to see this X out there just past the lunar terminator if you catch it just right. There's several photographs of this. I've caught it a few times where you can actually see the X just beyond the terminator with the very top of it illuminated. And every illumination pass during every different lunations isn't the same, because the sun angle can be different versus the next lunation phase. And you can also catch another feature called the Lunar V up in the Marinubium that's up north of that. Sometimes it's the same. Wendy Clark, when I was looking through Universe Today's Flickr page to see if anybody had caught these images, she had actually caught, and I saw you put it out on Instagram, the Lunar V and the Lunar X simultaneously, which I thought that's kind of cool. Some other features, we found the Lunar Q. Charles Wood on the Wiki Spaces moon page actually has a entry on all these letters. It's kind of partially filled out. I had some people on Twitter point me toward the Lunar S, which I had never seen before. But we wrote a compendium of these on Universe Today, and we put a challenge out there to try to fill in the last of these letters, so we could actually, it'd be neat if I could write astro guys in lunar craters. That would be kind of cool.
Yeah, I remember you brought in the Lunar X into the virtual star party one time. Yeah. We just the timing was just right, that we had a first quarter moon that night. Yeah, I do remember that actually. Now in your article, which of course you should go to Universe Today and read David's article, he's got the Lunar X, the Lunar V, there's a Q. How much of the alphabet is covered? Obviously O, so how much of the alphabet is covered there?
It's about 50%. I don't think I could find like a B or an A. I don't think a C would be too hard. I believe there is a D. I'd have to look through the entry again. There were some, I had never heard of the Lunar Q till I saw it. And I was like, actually, that's kind of cool. And like I said, the Lunar S I had never seen before. Some of these may be waiting to be discovered that, like I said, even though we see the same face of the moon toward us all the time, the illumination angle can change the shadow and lighting, where some features don't always look the same every time they pass the terminator. They can look slightly different. So some of these may be out there waiting to be found, just going through different images and stuff.
Yeah. Maybe it's the kind of thing that you'll feed into Google, right? Someone can take like a catalog of features on the moon, feed them into some kind of Google DeepMind and tell it to search for an alphabet. And then maybe you can get those. Like, have you ever seen those things you can do with galaxies, where you get like all the galaxies zoos turned up different letters made out of galaxies, and you can write
your name in galaxies.
Yeah, in galaxies, which is just a phenomenal thing when you think about it. You're, appropriating an entire 100 billion star formation so that you can write a clever message to somebody.
And it's more of an artistic than scientific endeavor, but it's kind of fun.
Yeah, it has its place. All right, so last story this week, we're going to talk to Morgan and talk about This Week in Musk.
Well, with 4 rockets now successfully returned to land after delivering their payloads to space, SpaceX has turned to thinking about when they're going to take one of those and relaunch it into space. And originally, they had been talking about doing this sometime over the summer. But Elon Musk announced in a tweet earlier this week that their current deadline or goal is sometime more like September or October. And they already have people who have expressed interest in delivering their payloads on this reused rocket. And that's a pretty brave endeavor, if you ask me, because they're going to be breaking entirely new ground here to launch a rocket, deliver a payload into orbit, land it, deliver or launch it again, and deliver another payload into orbit. So you can imagine that SpaceX will be offering a pretty big discount to the first people willing to take this plunge. But once they establish this as the regular mode of operation, then they'll be able to continue to reuse these rockets and just drive the prices of launches down lower and lower.
They're running out of room in their I guess, the big room, the locker where they put all of these rockets. I don't know if you've seen the picture. They don't have a lot of room left in them.
Yeah, they need to build a second floor onto
to their big hangar. Yeah.
But that's very promising because, especially early on, it's very unlikely that all of these relaunched rockets will have successful launches. They're going to figure out which parts are actually wearing at a faster rate than they imagined, or which parts become susceptible to stress in ways that they hadn't previously thought of. And I think it's very expected that there will be, I don't even want to call them accidents, because it's just trial and error to see what works and what doesn't when you're launching rockets over and over again for the first time ever. And so I think, just like we watched several rockets crater into drone ship desks, we should expect to see several mishaps along the way before they work out all the kinks and are able to start reliably relaunching these rockets.
Yeah, I think the first relaunch isn't going to be for a paying customer. They're going to, and then there's probably going to be discounts. So you'll just pay like 50% to use a refurbished rocket as opposed to an original rocket, and you can decide whether you want to take the risks. But the goal, of course, downstream is we get to this place where these things are launching hundreds of times, however, whatever is the lifespan of these rockets, we get a chance to see that and the cost savings that go along with that.
Yeah, that's absolutely right.
Yeah. And then, of course, the big question is what's going to be involved in making the Falcon Heavy reusable. And now, I don't know if you got a chance to see Elon Musk's interview. He was on the Code conference, and he was talking about what's the rocket that they're going to use to launch some of the even bigger things. And he was sort of hinting that there's something even bigger than the Falcon Heavy coming down the pike.
Well, the Falcon Heavy is will be a large rocket, but it'll still be smaller than a rocket like the Saturn V that delivered the Apollo astronauts to the moon. And if we're talking about going beyond the moon and even to Mars, as Musk has said he wants to make a priority for SpaceX, then they're going to need a rocket that's at least comparable and perhaps even larger than what we saw used in the 1960s and 70s to launch the Apollo astronauts.
I'm imagining like two Falcon Heavies bolted together, right? So you've
Falcon
got like
Uber Heavy.
Yeah, the ultra heavy, the uber heavy, that you've got like 6 boosters connected together, or maybe even 9.
They need a bigger bird name.
Bigger bird name than a falcon.
Pelican, the emu. It's not flightless. That sounds so good.
Yeah, I guess not.
Somebody in Kerbal needs to actually experiment with that.
Oh man, that's a great idea. Yeah. Kerbal Space Program. Someone should see what the limits are and provide that to Elon Musk as a demonstration and go, here, just rebuild, because we know that whatever happens in the Kerbal Space Program is very realistic to what's possible in real life. So, all right, well, I think we are sort of reaching the end of this episode of the Weekly Space Hangout. I'm going to say goodbye to some people, and I'm going to say, but before we do, I just want to once again thank the Weekly Space Hangout crew. You just do a search for WSH Crew. They're the ones who have been inviting all the guests and really kind of setting the kind of show that they want to do, and it's been great to just really be their puppet. And I really enjoy not even knowing sometimes who we're going to be talking to. It was a total treat to know that we were talking to Chris McKay this week, who I'm a huge fan of. So once again, if you want to be active and involved in the community and really be one of the people that helps run this show, go to the WSH Crew website. Just search for it on Google and you'll be able to find them. And of course, special thanks to Nancy Graziano for lining up a lot of the people that we deal with. So first thing I'm going to do is I'm going to say goodbye to Chad. There's Chad in Costa Rica.
Looks like you're sitting on the sun.
He's got a bright background, and hopefully Chad is going to be back here next week. and we're going to have a more fascinating, more little screens, more pictures. It's going to be maybe we'll have an intro coming. Anyway, it's going to be a better show. But this is just me being director, host, camera operator, all technical support and engineer all at the same time. So big thanks to Paul, Matt, Sutter. Paul, where do people find out more?
They can find out more by following me on Twitter and Facebook at Paul Matt Sutter, because that's my name, so it's easy to identify me. You can also listen to my own podcast, Ask a Spaceman. You can find that at askaspaceman.com, which is not as good as anything Fraser does, but can get you in between. If you've got to kill some time in between Fraser's episodes, then you give my show a listen. That's what you do. You can also help support the creation of those podcasts by donating to my Patreon campaign or account or whatever it is, patreon.com/PM Sutter.
Now, we're going to be doing a collaboration. Actually, the next episode that's coming out is going to feature Paul Matt Sutter, and we are going to be talking about virtual particles. What are they, and how do they go all wibbly wobbly?
They go wibbly wobbly. Yeah, that was my only answer.
Yeah, that was fine. It's fine. You made it work. So that's happening. That should be coming out on the Guide to Space. So if you haven't already, click subscribe wherever you're watching this, and then the next video, we just posted a video about whether you can have antimatter galaxies. I'm sure the answer will intrigue you. And this week, the next episode is going to be all about virtual particles, starring Paul Matt Sutter.
Yay!
Yay! Let's say goodbye to Dave Dickinson. David, and where do people find out more?
I am Astroguys with a Z, and I was active this week on Universe Today, Sky and Telescope, frequent contributor, and I'm blogging about and putting up all my Moroccan photos and travels as we're looking for interesting stories over here on Instagram. Also interesting, I just actually saw one of these for the first time. I was in NASA's Unexplained Files Season 3 for a few episodes. Apparently, they're running those episodes now. I've never actually seen them and I did this like a year ago. A lot of the weekly Space Hangouters, Jason Majors in a few episodes. I know Amy Shear Title did a few. I did this last year, and I kind of totally forgot about it. It's like, oh, yeah, somebody reminded me on Twitter. It's like, you know you're on TV now, right? It's like, oh, yeah, I forgot I even did that. So those are out right now. Again, like I said, I had never actually seen them. So the one I saw that somebody shared with me, actually, they came out fairly well. It was an interesting experience.
Awesome. All right. And last but not least, Morgan Rehnberg, where do people find out more?
Well, if you want to see some of the most exciting work from the next generation of science communicators, check out the hashtag ComSciCon16 on Twitter. While you're there, you can also follow me at Morgan Rehnberg or visit my website, morganrehnberg.com.
Awesome. Now, people wanted to know when Astronomy Cast is happening, and it's actually happening in half an hour. So we're going to be doing Astronomy Cast over on the Astronomy Cast YouTube channel, and that's going to be starting up in about 25 minutes whenever I can find Pamela. And then I'm going to go through this whole process again where I run another show and act like producer, engineer, camera operator, etc. So anyway, I just want to say a big thank you to everybody for watching. Once again, I cannot believe we just got a chance to talk to Dr. Chris McKay. What an honor and a treat. Thanks to the panelists for joining us this week. Thanks to Chad for talking me through virtually to running the show. Hopefully it's going to get easier and easier, and then you might be expendable, Chad. So just don't talk yourself out of a job. All right. So hey, thanks to all of you, and we'll see you all in 25 minutes or next week. See you later.
See ya.
And now I press the button. Here goes.